Okay, moving right along. Next up, we have Avni and Todd. This is a presentation that has most recently been very near and dear to my heart. Full disclosure, the reason that we are broadcasting this from the Intuit offices today, the home of Argo, is because I recently joined Intuit, very, very recently. These talks were planned before I joined, just again, full disclaimer. Oh, I'm hearing an echo all of a sudden. So like our closing keynote later and some of the other talks were already part of this. Intuit, as you all know, is a fantastic end user in the end user community, has won the End User of the Year award twice at KubeCon. So a lot of really great goodness in open source and in the cloud native community. And that's actually one of the reasons I joined, quite honestly, to have all of my worlds in open source and community come together. And another thing Intuit is amazing at is leveraging AI technology and building an incredible AI-driven platform. And so that is what our experts, Avni and Todd, are here to talk to you about today. Welcome, Avni. Welcome, Todd.
Thanks for having us.
Thanks.
Awesome. Well, with that, we're going to remove ourselves and over to you.
Sure. Thank you. Let me just go into present mode. Let me know if my slides are visible. Cool. Okay. Is my slide visible for folks?
Yep.
Cool. Okay. Hello, everyone, and welcome to Cube Crash, and welcome to our talk. So in today's session, we would be focusing on Intuit's platform and specifically from the AI native point of view. And I'm Avni Sharma. I'm product manager at the Intuit developer platform. And I also have Todd with me, who's the principal software engineer at Intuit developer platform. So just a brief agenda and topics that we would be covering. We would first go over the background of Intuit and Intuit's platform, the Kubernetes layer, and some of the challenges that come up for an end user by running, a platform at scale. And then we would go into how we've built an AI native platform with 3 broad pillars, which is around app-centric runtime, traffic management, and dev-friendly debuggability tooling. And in the end, we'll just close off with some takeaways and Q&As. So let's look at Intuit's background. So Intuit is a global fintech company that builds several financial products and services. So if you've used TurboTax for tax prep and QuickBooks for accounting and payroll, know that it is running on our Kubernetes-based platform infra, and it's running on an AI-driven expert platform. And to just lay emphasis on the AI power of the platform, we run about 40 million plus AI ops inferences per day. And we have a huge Kubernetes platform layer, and we call it IKS. Internally, we call it the Intuit Kubernetes Service. And it runs at scales, and we can see it in the numbers here. We have around 315 Kubernetes clusters, which have more than 16,000 namespaces and almost 2,500 services running in prod, and the pre-prod services are even more. And we have a budding developer community here at Intuit. We have around 1,000 teams and about 7,000 developers working on end user products. So we have a good developer footprint as well. And just to look at some of the persona that interact with the platform on a day-to-day basis. First, we have the service developer persona, and this is around, as I mentioned, 7,000 developers, which is huge. And the service developer persona is to focus on, building that app logic and shipping it fast. And let's look at the other persona, which is the platform persona. And platform engineering's overarching goal is to drive developer autonomy. And platform persona are those experts that help in driving that. And I know Whitney covered in her beautiful talk about platform engineering and the platform team. So this is just a recap. And yeah, the focus and the critical part of these platform experts, platform persona, is to enable our service developers by providing interfaces and capabilities in our developer portal so that the service developer persona can really accomplish their tasks. So to put into perspective, if a developer needs to manage an application on Kubernetes, that person doesn't need to spend years in understanding how Kubernetes actually works or any nitty-gritties. It should be really easy to develop and deploy their app without having to know a lot about the platform. And so let's look at some of the challenges that we came across and just laying some perspective as an end user company. So we did a lot of digging around in our Slack support channels. We conducted a lot of developer interview sessions to really understand the pain points that our service developers are facing today. And that has been classified into these three broad categories. The first one stands out. It was the biggest pain point, which is around a very steep learning curve. So when a developer is trying to do any service development or deploying it on the Kubernetes layer, they often found themselves dealing with a lot of Kubernetes internals and APIs, and a lot of configurations to take care of. And let's say if there was something misconfigured, there wasn't enough troubleshooting help around that. So that was one of those pain points. Second one is more around the inner loop, which is around local development with dependencies, essentially managing environment-related issues when you're trying to develop locally, which also then translates to longer deployment times, and dev to prod becomes more painful and harder. And the last one is around tech refreshes that need migrations. So the current state is that whenever we do an upgrade or introduce a new tech stack or a new feature, we ask devs for their partnership for these migration programs, which can be burdensome on the developers, and then they have to spend time apart from coding on these tech refreshes migrations. So just to put into perspective as to the steps today that the service developer takes. So on our developer portal, a user goes, creates a new asset. So we do have paved-roads that enables developers in creating their services on our Kubernetes platform. And the atomic form of deployment, internally we call it an asset. So the user would go ahead, create an asset, and then develop and deploy their application. And then their journey starts of configuring, those Kubernetes primitives in the deployment repo, configurations like PDBs, HPS, what have you. And then they would go ahead and onboard to API Gateway to expose the app to the internet. And if they happen to have some sort of internal communication or east-to-west traffic, they would also have to onboard to Service Mesh. And after doing all of the configuration steps, they would have to then test the app for the end-to-end testing. And now if they want to run any sort of load test in a particular cadence, they would do this for perpetuity by configuring min-max for HPA. And as I mentioned, any tech mandates for migrations, they would have to perform that as well. So this can really make a service developer go crazy. So now they not only have to focus on building the cool features, but they are also dealing with a lot of infrastructure burden and a lot of cognitive burden there. And this is our target state, and this is where we want to be. And what we essentially want to do is that we want to translate the application needs to platform means. Meaning that a user should only be in the context of their application and what the application requires, instead of having to translate it to what does it mean in the platform terms. So essentially, only these 3 points, that is creating an asset, developing, deploying, and testing, are really their focus areas. And everything else needs to be enabled by the platform automatically. And now I would like to pass it on to Todd to show us how we overcame these challenges and reached to our target state. Yes, Todd.
Yeah, thanks, Avni. Just to set some context, I'll briefly describe Intuit's development platform, which we call Modern SaaS Air. At the top, we have our developer portal, which is our IDP, which provides the developer experience for all of our engineers. The complete lifecycle of an application is managed through Dev Portal. And like Avni mentioned, we refer to those as assets or software assets. Underneath that, our platform is based on these 4 pillars: AI-powered app experiences, Gen AI-assisted development, app-centric runtime, and smart operations. And we also have our operational data lake that provides a rich data set for visibility into how all of our applications are developed, deployed, and run. And really, this data lake is critical for some of these future capabilities that AI will enable, because as we all know, data really drives AI. But the focus of this talk is the runtime and traffic management component we call IKS Air. IKS Air is a simplified deployment and management platform for containerized applications running on Kubernetes. It provides everything an engineer needs to build, run, and scale an application, with the main components being an abstracted runtime environment, unified traffic management, and developer-friendly debug tools. If you stay on that slide for a second, if you build and run your own platform on Kubernetes, you likely have these same types of concerns, and hopefully this talk sparks some ideas for your own system. But I'll go over the first 2, and Avni will cover the debug tools. As Avni described earlier, we faced a number of challenges in the over 5 years that we've been building and operating a developer platform on Kubernetes. And our current paved-road runtime is a result of all those learnings. We provide our developers with an abstraction that allows them to focus on their application and shields them from the Kubernetes version updates and other platform changes. The abstraction also implements best practices for application resiliency and provides automated rollbacks. We also provide intelligent autoscaling to efficiently manage the resources needed to run the application. The application specification abstracts and simplifies the Kubernetes details that you see on the left and provides an app-centric specification like on the right. And as Avni was mentioning earlier, we want the developers to really focus on their application and what the application needs are, not so much on the implementation behind the scenes in the platform. So the platform takes the responsibility for generating the actual Kubernetes specifications that are then submitted to the clusters. Our application spec is heavily influenced by the open application model and describes the application in terms of components, which are then customized or extended using traits. Components represent individual pieces of functionality, like, for example, a web service or a worker. And then traits can modify or change the behavior of the component that they are applied to. Through this system of components and traits, developers can define what their application requires from the platform without them really needing to completely understand how it's all implemented on Kubernetes. A good example of this complexity is the progressive delivery solution utilizing Argo Rollouts and Numaflow that the platform creates to enable automatic rollback of buggy code. So this is a pretty complex solution that our platform abstracts away. So under the covers, when a new version of an application is rolled out, canary pods with the new version are first created, and some percentage of that traffic is sent to them. The metrics of those canary pods are then analyzed by a Numaflow pipeline, which generates an anomaly score. And if the anomaly score is low, like here where it's a 3, then the rollout would continue. But if it's high, like above 7, Argo Rollouts would stop the deployment and revert to the prior revision. This is an important aspect of how we allow our developers to deploy with confidence without really needing to know how to set up such a complex solution. Our platform also automatically recommends scaling solutions for applications. To do this, it needs to determine the application resource sizing, like memory and CPU, but also handle unexpected events like kill or eviction. Next slide. It also needs to handle horizontal scaling to ensure the applications properly run at scale with varying levels of load. It needs to identify what metrics the applications would be scaled on, as well as the minimum and maximum number of replicas required. So as you can see there, these are all primarily data-driven problems, and we believe AI will have a big impact on capacity planning and autoscaling, and as was mentioned in the previous talk, on scheduling. This allows us to be more efficient with our computing resources. So we're building an intelligent autoscaling recommendation system that reduces the burden on our developers, helps us ensure our workloads have the resources they need, and improves the efficiency of our platform. The details of this is beyond the scope of this talk, but the basic idea is that we have components running in the cluster handling short window scaling operations and emitting metrics that are then analyzed by a group of machine learning models that make long window capacity and scaling recommendations. The solutions to different scaling problems are then applied back to the clusters. Another big challenge we've identified for our developers was configuration and management of network traffic. While some applications need to use some very specific features of our networking environment, we found that most only need to change a common set of configurations. Our solution simplified the endpoint management, unifies the configuration of our API gateway and service mesh, and provides a graduated level of complexity as needed. So for example, here's a screenshot showing the traffic configuration for a service on our developer platform. Most applications only need to configure their routes and throttling. But if needed, they can toggle, next slide. But if needed, they can toggle on advanced configs and get access to cores and OAuth scopes. And for even more complex use cases, they can edit the underlying YAML configuration. Now I'll turn it over to Avni to talk about debug tools.
Thanks, Todd. So yeah, we went through how we've created an abstract platform to really start leveraging and providing those AI capabilities to our service developer. And with abstraction comes the issue around debuggability. So once the platform is abstracted, another challenge that our service developer started to experience was around these debuggability experience. So we all know that abstraction and debuggability, it does not go hand in hand. So it was really critical to provide our service developers with a paved path for debugging their services. And so now our service developers don't really need to understand any Kubernetes primitive or have any historical knowledge of the platform. Also, with this whole debuggability experience, we made an attempt to democratize the debug tooling across teams, where we saw folks juggling with best practices and a lot of different tools. And all of this would also help us in reducing MTTR and providing a very dev-friendly debugging workflow on our internal developer portal. So one of those experiences, the first one is providing shell experience by using ephemeral containers. So as I mentioned, in an abstracted platform, a service developer has no access to namespace and pod directly. They would not be able to kubectl exec in a pod or even fetch any kube config for that matter. And so it became really critical for us to provide them means to debug their app container. And for that, we have used ephemeral containers, which is GA feature in your Kubernetes 1.25 version. And so essentially, this will enable in providing a shell type interactive debugging experience to the user. And ephemeral containers are really ideal for running a transient container that is custom built for debugging and troubleshooting. So now you can launch a debug container into an existing pod where your app container resides. And this debug container, which is the ephemeral container, would share the same process namespace, PID, IPC, and UTS namespaces of the target container. And given that the containers in a pod already share their network namespace, this debug container is set up perfectly to debug issues in the app container. And ephemeral containers are also very valuable solution for interactive debugging and interactive troubleshooting when kubectl exec is insufficient because a container has crashed or a container image doesn't include debuggability utilities. And the latter, where the container image does not include these utilities, it's a pretty common practice in many orgs where the container images are hardened. So this is also critical there. And this is just a very small video of how we are exposing this on our developer portal. So a user goes, clicks a terminal icon, selects the pod to which they want to attach the container with, and it spins up a interactive shell session with the app container. And we can see that a connection was established. And here you can bake in all of your debuggability tooling, which is also approved across the organization. The other part of debugging is our one-click debugging or on-demand debugging. And for this, we've used Argo workflows. And Argo workflows is ideal to define the sequence of steps needed for any debugging workflow. So we also see that we need specific debugging techniques based on the language and framework. And this is really necessary to preserve application context like application structure, code references, and so on and so forth. And at Intuit, the top two used languages are Java and Golang. So we made tooling for these languages. So for Java, we have utilities around thread dump, heap dump, dynamic logging. And for Golang, it's stack traces. So this is a simplified workflow. If a user sees a troubled pod, so let's say they are looking at their wavefront and they figure out they have any sort of 100% CPU utilization or memory leaks, they can go on dev portal and trigger any of these app-specific action with one click. So just to lay some context here, this is how it looks like on the portal. And a user can select the specific action they want to perform on their application pod. And when they go, they would hit drop-down icon over here under select host. So they are essentially selecting a pod. They would add it to debug list. And what add to debug list does is that in the background, it would spin up a debugging namespace and invoke an Argo workflow, which is catered to that particular action. In this case, it's a thread dump. And then once the thread dump is triggered, a user can download it. After the action is completed, we upload that artifact to S3. It's available for 24 hours. And so this whole flow is really seamless to use. And now a user does not need to find the debugging ninja in their team. This is completely frictionless experience. They don't have to access the pod by kubectl exec. And all of this is also pretty guardrailed because we sanitize our thread dump artifacts and heap dump artifacts. And we also know the best way to take these actions on those pods. So yeah, concluding with some key takeaways and benefits for our developers. So definitely when our developers can focus on their app logic, it really helps in increasing developer release velocity. And by offloading a lot of the cognitive burden, now platform teams can perform migrations and service owners need not participate in tech refreshes. And this also reduces the amount of time for getting a service into production, since a lot of the things, because of the AI capabilities, are out of the box and we configure it dynamically. The service can go into production quickly. And since the configurations which are related to platform are managed by us, it also helps in reducing any potential incidents that might have been caused by any sort of misconfiguration. And definitely the intelligent autoscaling manages our service availability. And yeah, a shout out to Intuit. We here at Intuit believe in open source and open collaboration. And as Lisa mentioned during the start of the talk, we have been a recipient of the End User Award in 2019 and 22. We've created and open sourced many open source projects, and one of those famous ones are Argo CD. And if you want to learn more about open source at Intuit, feel free to go to that link. And yep, that's the end of our talk. And any questions? Are we addressing questions live, Lisa?
Yes, we are, and you have lots. Actually, one of the questions was about open source. So let's, I think it was the Philip's question. Well, actually, there's a ton of questions, but let's just start with this one. So it looks like your application spec is a Kubernetes CR. Are you using a Kubernetes operator, in-house custom built, or perhaps something like Crossplane?
Yeah, I can take that. Yeah, so our application spec is is a CR, it follows the CR conventions, and it is in-house built. Currently, that CR is rendered in our deployment pipelines, so it's not an operator in the cluster. It's actually a process in our pipeline that takes that CR and converts it to a rendered Kubernetes manifest. But we have considered if it would be better to put it into the cluster itself. But as of right now, it's in our pipelines. But yes, we could use something like Crossplane or some other, or just a natively built operator to manage that.
Okay, good stuff. We have a question from Siva. Is the ephemeral container image available as open source? Please share more details like image name.
We haven't pushed it. So at Intuit, we only allow consuming images from our own internal image repository, and we don't publish images except for our open source projects. We don't publish images to publicly accessible image repositories. But honestly, it's a very simple debug container. And we'll take it as feedback. Maybe that is something that would be worthwhile sharing with the community, because it's really building in a lot of tools that would be common for most people. So yeah, it's not available now, but we'll take that as feedback to consider if we can open source that.
Okay, there's a lot of questions. I'm trying to decide. You guys can upvote and downvote questions. I think we can see on one of the other many screens we have here. So how are,
sorry.
It's okay. I was just going to read Raj's other questions. How are there any security and auditing concerns addressed with your approach with ephemeral containers?
Yeah, that's an important question. We did take this whole ephemeral container approach through our security review, our own internal security review, and one of the biggest things was to make sure that the mechanisms for how those ephemeral containers are launched are properly safeguarded, and also the container itself needs to be hardened, as Avni mentioned. By default, all of our application images are hardened with only the bare essentials required to run the application is on the image that's used at runtime. And for the ephemeral container, we don't have any ability to, once you're in the ephemeral container, there's no package management. There's no ability to load things, to side load things into that ephemeral container. It's only the utilities that we've intentionally installed. So those are some of the guardrails that we put on there.
Okay, sounds good. Let's go with Budav's question next. Autoscaling is part of Kubernetes itself. Can you share a simple use case of autoscaling with AI? You were talking, like what you were talking about, is it to guess the memory and CPU based on the application?
Yes. So one of the biggest challenges is understanding what metric to scale on for HPA and what thresholds to set for that metric for scaling for HPA. And also even just the container itself, how much memory and how much CPU should you request for that container? And if you think about it, it's really a data exercise. You observe the application running, you look at, the TPS and the memory and CPU that's consumed by handling different requests. And all that can be automated using AI. So we're automating both, so there's in-cluster runtime autoscaling that's still done by HPA as normal, but we have a secondary process that makes long-range predictions for both pod resources and HPA metric configuration.
Okay, I think kind of a follow-up to that, Siva's question. What tools do you use to suggest memory and CPU, and can you recommend some limits, or do you request limits?
Yeah, so we have a few different, so some of the recommendations are done through traditional ML pipelines. And we also have some recommendations using Numaflow, which is an open source project that we've released that allows you to do ML pipelines inside the cluster. So it's a combination of some proprietary ML pipelines as well as Numaflow.
Okay, and for those of you that don't know, Numaflow is quite new. Numaproj is the open source project that the little teddy, the polar bear on the screen. That's the project that you might not know about that has been referenced several times today. And if you come to KubeCon and you come to the Argo or the Intuit booth, they will be handing out these little guys and some octopus.
Yeah.
Okay, there's so many more questions. We're not going to be able to get to them all, so I hope you could stay around and answer some
Sure.
of them in the chat, but maybe we can take another one. Let's see. How are you managing Argo CD across 300 plus clusters?
That's another good question. So we have clusters broken into different BUs, different business units within Intuit, and we roughly have one Argo CD server responsible for some subset of clusters that apply to a certain BU. And so, yeah, we do have, I think, about 20 different Argo CD servers managing those 315 clusters, and it's sharded based on business unit.
Okay, awesome. Oh, cool, JD. Thanks for putting the link in there if anyone wants to get involved and contribute. So, I mean, how are we doing on time? There's so many questions.
Well, so if you could stay around and look and answer some of the questions,
Sure.
It would be really appreciated. There's loads of them for you. So
there was one question that I think we can take, which would be hard to type in, but I just want to give a shout out to one of the questions earlier was asking how we are educating about this developer platform. And partially, I think that's going to be my job. So I'll take that one a little bit. But I do want to say we have, as Todd and Avni mentioned, so many open source projects going on here at Intuit that many engineers are dedicated to. And so we have an Intuit open source LinkedIn page that you can join and follow along. It's different from the branded Intuit consumer products. It's Intuit open source LinkedIn. So that's where we publish a lot of our education and our blogs. We have a Medium blog that you can join as well. So there's a lot of places that will be making these type of announcements. I know from being in the community and from being a CNCF ambassador for many years that I did not know that Intuit was responsible for the origination of Argo. And I did run the first ever Numaproj meetup. So I'm very happy about that. That was over a year ago before I even thought about joining the company. But I, as a pretty solid community member, did not realize how much open source involvement that Intuit is doing. So since I've joined, I've started making signs that talk about GraphQL and Numaproj and ArgoProj, and just so we can get more of the goodness of open source that is being devoted to. But do join the blogs and the LinkedIn group. I was wearing an Intuit open source shirt earlier. If you come to one of our meetups, then you get swag like that. So there's lots of ways, but there'll be more to come now that I'm here and will be.
And if I could just maybe say a couple words about that. So I think Intuit is in a unique position in the sense that we're not a vendor. We're not selling Argo CD. We're not selling Numaflow. This is our way of giving back to the community and sharing what we're building internally. And of course, we have commercial products like TurboTax and Credit Karma and QuickBooks Online, but we're not selling, Numaflow or we don't really have a business model for that. It's really our way of giving back to the community.
Awesome.
Thank you for that.
Well, thank you so much for being here. And with that, we're going to remove you from the stage.
Thank you, but we
All right,
won't.
thanks, everyone.